Hi guys, today we're going to do lesson 13. In lesson 13, we're going to be working on subtraction. And with subtraction, we are going to work out how to decompose numbers. So that would just be like regrouping or borrowing. In the Eureka way, we borrow for all of the numbers before we even start subtracting, which I think is an amazing way of doing subtracting. So make sure you keep an eye out for that. And then I'll be pausing the video and doing some extra questions together. Make sure you are following along with the video and doing pausing and practicing the questions that she gives you along with her. Make sure you're using your place value chart. So you should have your place value chart in your clear sleeves so that you can write on it with your dry erase marker. And you should also have your dry erase board to write on.
Hi friends, welcome to Module 1, Lesson 13. I'm Mrs. Gradney, and today we'll be using the standard algorithm for subtraction, decomposing to smaller units once, and applying the subtraction algorithm to solve word problems using tape diagrams. Here's what you'll need for our lesson today. Let's get started. Read this problem with me. 4,259 minus 2,171. I'll draw a tape diagram to model this problem. Now, what's the whole? The whole amount is 4,259, and we can label that at the top. We make sure to draw our arms going end to end to show that the whole tape has a value of 4,259. I also need to label the part that we know, 2,171. When we think about how big to draw the parts in our tape diagrams, we can use estimation. Here, I know that 2,000 is half of 4,000. So tell me when to stop to draw my part. If you said stop somewhere around here, way to go. Now I can label the part that we know at the bottom, 2,171. And we can label the part that we don't know yet with a variable. I'll use A this time. Pause the video now and record this problem vertically, like mine is, and also draw the tape diagram.
So go ahead and record your problem and draw your tape diagram on your whiteboard.
Now we're going to model this problem using place value discs on our place value chart. When we're modeling subtraction using place value discs, do we need to draw discs to represent both numbers or just one of them, and why? Pause the video to talk out your thinking.
Do you think we should draw both numbers or just one of the numbers when we are subtracting?
Hopefully you said that we only need to draw discs to model the whole, 4,259.
So she refers to the number 4,259 as the whole. And the reason why she refers to it as the whole is because if you look at your tape diagram, you can see that the whole piece of tape is represented by the number 4,259. So that is our whole, and then the bottom number is part of the whole, and we are trying to find the other part of the whole.
The part, 2,171, is already part of the whole. It's inside the whole. Pause the video now to draw discs to model 4,259 on your place value chart.
You should be able to draw these discs on your place value chart really fast. So when you're done, unpause the video so she will move on with her solution.
subtract using the standard algorithm, we're going to be asking ourselves some questions over and over. The first question is, are we ready to subtract? We'll determine if we're ready to subtract by looking across the whole from right to left to see if there are enough units to subtract. Here's the next question we'll ask ourselves. We'll look at each unit and ask ourselves if there are enough of that unit in the whole to subtract the number of that unit in the part. Let's start with the ones place. Are there enough ones in the whole to subtract the ones in the part? Yes, there are enough ones because 9 is greater than 1. That means we're ready to subtract in the ones place. Let's move to the tens column. Are there enough tens in the whole to subtract the tens in the part? No, there are not enough tens because 5 is less than 7. So where can we get more tens? We can get more tens from the hundreds. Watch what I can do. I can decompose 100 into 10 tens.
When you decompose your numbers on your place value chart, they should look exactly the same way as our Eureka teachers do.
I have 115 tens. I can show that same thinking in the algorithm, like this. I had 200s, but I decomposed 1 to make 10 tens. So now I have 115 tens.
She is doing a very good job at identifying all of her place values. Notice how she said she had 15 tens. Well, she has 15 in the tens place. And now she has 100, so 1 in the hundredths place.
Video to show these changes in your place value chart and in the algorithm like mine.
So if you have not reflected these on your place value chart or in your algorithm, then go ahead and do that right now.
Now let's move to the hundreds and see if we're ready to subtract. Are there enough hundreds in the whole to subtract the hundreds in the part? Yes, there are enough hundreds because 1 is equal to 1. Are there enough thousands in the whole to subtract the thousands in the part? Yes, there are enough thousands because 4 is greater than 2. So are we ready to subtract? Ready, 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 ready. I always like to go back and double check each column just to make sure I didn't miss anything. So yes, we are ready to subtract.
So she's taken and regrouped in every single place value that she needs to regroup in before she subtracts. So this is a great strategy that I expect you guys to be using so that you don't end up messing yourselves up, because a lot of times fourth graders just subtract the numbers and don't even think about if they need to regroup or not. So in this case, they might subtract 7 from 5 and get 2, and their answer is going to be very wrong. So make sure that you do all of these steps that you're learning in these videos.
So let's subtract. 9 ones minus 1 1 is 8 ones. 15 tens minus 7 tens is 8 tens. 100 minus 100 is 0 hundredths. 4 thousands minus 2 thousands is 2 thousands. Let's say the whole number sentence. 4,259 minus 2,171 equals 2,088. So what's the value of A in our tape diagram? The value of A, our unknown part, is 2,088. So we can record that underneath our tape diagram like this. So what can be added to 2,171 to result in a sum of 4,259? Well, in our tape diagram, we can see these two parts, and we know that two parts can be added together to make a whole, or the total. So 2,088 can be added to 2,171 to equal a sum of 4,259. Let's try another one. Let's read the problem out loud together. 23,422 minus 11,510. Pause the video now and record this problem vertically like you see here, and also draw a tape diagram to represent the problem. Label the whole, the known part, and label the unknown part with variable b. Welcome back. Do you remember the question that we ask ourselves first when we want to subtract? Are we ready to subtract? So let's look across the digits from right to left. Are we ready to subtract? No, we're not ready to subtract. So let's get ready to subtract. Now we'll go to each column and we'll ask ourselves if there are enough of that unit in the whole to subtract the number of that unit in the part. Let's start with the ones place. Are there enough ones in the whole to subtract the ones in the part? Yes, there are enough ones because 2 is greater than 0. Are there enough tens in the whole to subtract the tens in the part? Yes, there are enough tens because 2 is greater than 1. Are there enough hundreds in the whole to subtract the hundreds in the part? No, there are not enough hundreds because 4 is less than 5. So where can we get more hundreds? We can get more hundreds from the thousands. We can decompose 1,000 into 10 hundreds. So then we'll have 2,000 and 14 hundreds. Now we're ready to subtract in the hundreds. Let's move to the thousands. Are there enough thousands in the whole to subtract the thousands in the part? Yes, there are enough thousands because 2 is greater than 1. And are there enough 10,000s in the whole to subtract the 10,000s in the part? Yes, again, because 2 is greater than 1. So are we ready to subtract? Ready, 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 ready. Yes, we're ready to subtract. Pause the video now and subtract each unit. As you subtract, whisper the subtraction in unit form. Did you find the difference to be 11,912? Now we know the value of b in our tape diagram is 11,912. So look at your tape diagram. What can we add to 11,510 to get a sum of 23,422? We can add 11,912 to 11,510 to get a sum of 23,422. So then how can we check our answer to a subtraction problem to make sure that we did it correctly? We can add the difference to the part we knew at first to see if the sum we get equals the whole. If it does, we know we did the subtraction correctly. If it doesn't, then we need to go back and find our mistake. Pause the video now and check our subtraction by adding 11,912 and 11,510. So what sum did you get? Hopefully you got a sum of 23,422. What does that tell us? Since it's the same as the whole in our subtraction problem, that tells us that we subtracted correctly. Let's try a word problem now. Remember, when we solve word problems, we use the RDW process to help us make sense of them. We read, we draw, and we write.
When you read the problem, remember we've been reading our problem twice. The first time is to get the gist of the problem, and then the second time is to point out what is the important information. And then when we draw, a tape diagram is an acceptable drawing for your drawing. And then when you write, you want to write we've been practicing writing our answer with our unit, but eventually we're going to write out the whole sentence.
So let's read the whole problem together. Ready? Read. The paper mill produced 73,658 boxes of paper. 8,052 boxes have been sold. How many boxes remain? Now, before we dive in and start drawing, let's take a moment to think about what we know and what we're looking for. Pause the video to talk out your thinking.
So this is when we would read the question the second time and work through what we need to know. So we have the paper mill produced 73,658 boxes of paper. 8,052 boxes have been sold. How many boxes remain? So we know how much total paper we have. We know how many boxes have been sold, and now we need to find how many boxes remain. So if we're drawing a tape diagram, our total or our whole is going to be 73,658, and then part of our whole, which would be the part sold, would be 8,052. So we need to know how much is left.
I was thinking that we know the total amount of boxes that the paper mill produced, and we know how many boxes have been sold, and what we're looking for is how many boxes they still have. Pause the video now and draw a tape diagram to represent the problem. Represent the unknown using a variable. Welcome back. Does your tape diagram look similar to mine? What can you tell about the relationship of the numbers by looking at our tape diagram? Use the words part and whole in your explanation. Hopefully you said, we know the whole. That's the total amount of boxes of paper that they made. We also know a part of the boxes, the part of the boxes that they sold. And we're looking for the other part, the boxes that they still have. When we know the whole and a part, and we're looking for the other part, we can subtract. Pause the video to set up the subtraction.
Okay, we're gonna work through the subtraction together just so we can get some extra practice. So here is my tape diagram I set up and my subtraction problem. So we're gonna go through and ask ourselves questions just like our Eureka teacher did. So the first question she asked is, are we ready to subtract? So we're gonna go through from right to left, from right to left, from our right side to our left side, each different place value to make sure we can subtract them. So in our ones place, can we subtract? Yes, because 8 is greater than 2. In our tens place, can we subtract? Yes, because we have 5 and 5 and those are the same, and those can easily be subtracted. In our hundreds place, can we? Well, yes, 6 is greater than 0. In our thousands place, can we subtract? We cannot. We are not ready to subtract in our thousands place because our 3 is less than our 8, and we cannot take away something greater from something smaller without getting a negative number, and we don't want negative numbers in our 4th grade subtraction problems right now. So we're going to have to borrow. Where are we going to get 10 more thousands for our thousands place? We need to borrow them from our 10,000s place. So we can take 1 10,000 from our 10,000s place and get 6 10,000s. And when we take 1 10,000, that makes 10 thousands. that we can add to our 3 in our thousands place to get 13,000. So now in our thousands place, are we ready to subtract? Yes, because 13 is greater than 8. And in our 10,000s place, we have nothing to subtract, so we're good to go there. So now we're going to go ahead and subtract. 8 minus 2 is 6. 5 minus 5 is 0. 6 minus 0 is 6. Ooh, we should be subtracting. Let's go back. Let's go back and subtract using our unit form. 8 ones minus 2 ones equals 6 ones. There we go. 5 tens minus 5 tens is equal to 0 tens. 6 hundreds minus 0 hundreds equals 6 hundreds. 13 thousands minus 8 thousands is equal to 5 thousands, and 6 10,000s minus nothing is equal to 6 10,000s. So our answer here for B should be equal to 65,606. And think about what we're going to do to make sure that that is the correct answer. We need to take this part and add it to this part to see if we get our total. So we're going to do that right now. Let's add together. 6 ones plus 2 ones is 8 ones. 0 tens plus 5 tens is 5 tens. 6 tens plus 0 tens is 6 tens. 6 hundreds plus 0 hundreds is 6 hundreds. 5 thousands plus 8 thousands is 13 thousands. And 6 10,000s plus our 1 10,000 equals 7 10,000. So we have 73,658 here and 73,658 here. So we know we are correct.
Be careful to line up the units. Ones with ones, tens with tens, and so on. Are we ready to subtract? No, we're not ready to subtract. So pause the video now, get ready to subtract, and then complete the subtraction. Check your work using addition, and be sure to write an answer statement. Hopefully you found 65,606 boxes remain. Compare your work with mine and make any changes if you need to. I think we're ready for the problem set. Your must-do problems for the Lesson 13 problem set are on the screen. Set a timer or watch the clock for 10 minutes and work on these problems. If you finish the must-do problems before the 10 minutes are up, feel free to try any of the other problems on the problem set. Today, we used the standard algorithm for subtraction to solve word problems, and we checked our work using addition. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!
You guys did an amazing job today. Make sure when you are subtracting and doing your practice problems, you check to make sure you are ready to subtract before you subtract.